Hello again, this is Chapter 3 and Object Creation. We're going to have a look now at how we can create objects, and we're going to use the clock display project and the clock display class to consider this. This video will not show a detailed understanding of the internal and external view of clock display. This video will show the concepts needed to understand the internal and external view of clock display class. However, if you want to go and have a look into the clock display, into the code, just to give you some sort of things to consider and think about, then have a look at exercise 3.23 and 3.24 on page 78 of the book. So, you've seen how we can create objects using BlueJ. So we right-click on the class, and then we can create that object. When we right-click on the class, we get the constructor, and sometimes the constructor requires a parameter, and sometimes the constructor doesn't require a parameter. So we can go ahead and create it that way. As we've also seen that those objects, they store primitive types in their fields. So we've seen, for example, price and balance in previous projects, and in the recent project we've seen the limit and the value fields as integers. We can also store other objects as fields in objects. So an object can have different objects within its fields. So if we think about our car analogy, that makes perfect sense. We can have a car object, but within that car object you may have different objects within that within the state of it. So for example, you could have a spark plug object, which could be represented maybe in code within that object. So objects can store our objects. Looking at the fields previously, here's our the primitive types which we've used previously in number display, and we've got an integer type for limits and integer type value. We've got the constructors and methods omitted there. Now just a quick word on primitive types before we go into the objects. You need to really have a good understanding of these 8 different primitive types which are available. So if you look at Appendix B, pause the video now and have a quick look at Appendix B, because you will be expected to know how to use these different primitive types. At this point here, I want you to notice the primitive types are all shown with a lowercase at the start. So byte starts with a lowercase b, for example, and they're all shown in lowercase. Now, primitive types really are in the language because they've been in programming language for many years. Before object orientation came around, they were used. So primitive types are in the language. But the real beauty of object orientation is the use of objects. So we're going to go into how we use objects as opposed to just primitive types. If we look in the clock display class, we're going to give a video with a detailed consideration of the clock display class later, but if we just consider how it looks at the moment, if we look into the fields, we'll see that we've got 2 new fields created there. Now, as in the number display class, we had 2 fields of type int. We've now got 2 fields of type number display. Now, that number display type is we've created the objects of the number display, and so now we can create a number display object in code. So we've created it by right-clicking on the object, but now we can actually create it in code, and this is how to do that, calling that line there. Private number display hours. So that will give, obviously we've got the access modifier there, and we've got the name of the type. So in previously it was int, but now it's number display, and then we have the actual name of the variable itself, which is hours. So the main things to note at this point here is that the number display is all in capital letters. A class will always be shown in capital letters, whereas primitive type will always be shown in lowercase. So that's what we're going to look at now. If we have a look, once you create an object in BlueJ of clock display, if you go in and then inspect it and have a look at the state, you're going to get this. This is what it looks like. We've got our number display hours and our number display minutes. So we've got our 2 different fields. Now, previously, when we looked at our state, we had 2 fields of type integer, and then we had a type string as well, potentially. Now we've got objects being stored as the type. Now, we can't show all of the values of the objects. What we do is we show this as an arrow, which is a reference. we can then double click on that arrow, and that will take us to the actual object of the number display, and then that will show us the limit and value fields within the specific number display object. Remember here, we're actually creating two objects of the same type with our clock display. So by creating two new number displays, we effectively do this. We've got a class representation there, or an object diagram here, where we've got my clock display object, and that creates the two references to the two number display objects. There's some example fields there of 1103 shown there. So that's our object diagram. Comparing a class diagram with an object diagram, the class diagram, we can use multiplicity to show a different amount of displays, but effectively the class diagram will only have one class there because the objects haven't been created. Compare that with the object diagram, which shows all the objects created within another object. Now you can imagine with many objects creating other objects, which in turn are then creating other objects. As we progress through this course, our object diagrams are going to get quite complicated with lots of different objects being considered. But all we're doing is trying to represent and show how the different objects have been created. Going back and looking at our clock display class, which we're going to look at in a second, this shows our three different fields we've got. So we've got our two number display type fields, and then we've also got a single string type field called display string. You're going to see that the constructor to create the clock display object doesn't take any parameters, and it simply creates our new objects. Now, this is the new here as far as you're concerned. When we create new integers, it's a little bit different to how this is. So if I just put in what a new int would look, if we wanted to create a new int, we'd say int, or we'd say, if the hours was actually an integer, we'd say hours equals 3, or 24 in this case. However, hours is not a primitive type, but it's a more complicated object, so we can't do that. We have to call this keyword, which is the new keyword. So what we say is we say hours equals new number display, and then we open up the parentheses there, and we put in our parameter. If you can remember when you created the number display object using BlueJ, you did a right click and it asked you for a parameter. This is exactly the same, except the only difference is we're doing it in code as opposed to with you right clicking on the object. So what we create here is this syntax here is what's used every time a new object is created. Hours equals new, and then the type of object, which in this case is number display, and then 24, which is the parameter. The next line is exactly the same. The only difference is we're creating the minutes object as opposed to the hours object. So again, we need to use the new keyword, and then we use the number display class name, open parentheses, and then the parameter which is required, close parentheses, and then the semicolon. So that's what we're doing there. That's how we're creating our objects. Again, we can create those objects in BlueJ by right-clicking on the class, but now we're creating it in the code. So here's the breakdown of that. I've got a new bit of terminology here for you, the actual parameters and formal parameters. So in the clock display constructor, when we create our number display object, we're using an actual parameter. The actual parameter is sort of the number itself, so 24. If we look in the number display class and in the constructor, which you've been working on previously, we'll see that when you create a number display object, you have to put in the formal parameter. Now the formal parameter is simply, it includes the type and the name of the parameter being used. So in this case it's int rollover limit. So actual parameter is just the number 24, formal parameter is the name of the parameter. So here is an object diagram which is a little bit more detailed now. We've got our clock display object, which has created two number display objects. That's shown by two little arrows in a box on the hours and minutes on the clock display. That then points to one number display object with a limit of 24 and a value of 15. And then another number display object which represents the minutes, which is a limit of 60 and a value of 23. So that then gives us a full object diagram of our clock display there. A little bit on assignment with using references compared with values. So you've all got used to now using integers and creating integers, so you can create some variable and then equal it as some value. So for example, you can have an int a equals 5. Obviously you need a semicolon on that one there. When we're using objects, it's a bit different. As we've discussed, when you use an integer, you can have a number. So for example, here we've got an int I equals 32, whereas in objects we can't represent, generally we can't represent objects by individual sort of numbers or as fields, or as for example 32 there. So rather than creating a value, we have a reference. So the primitive types give us values, whereas the objects give us references to the object where it has all the actual fields. Therefore, when we copy objects, we get copies of the reference, whereas when we copy primitive types, we get copies of the number. Now, the way this works is if we there say for that int b equals int a, that means that there's literally the value. So if I now change int a, then the int b value doesn't change. So if I make a equals 3, then b still equals 32. That's different with objects. If I say that a equals or b equals a from an object perspective, it copies the reference. So then if I change any of the fields in either object A or object B, then both object A and object B will change because they're both pointing to the same thing. Whereas primitive types point to specific numbers and store their numbers, the objects will store the actual reference to the objects. Let me just bring up a little diagram to make help with that. So if we can remember, the sort of the memory analogy here, we say here that here is our integer called a equals 3. This is an area in memory, and then we've got another area in memory here equals a equals, and we're going to make b equal 3 as well. So what we do is we put in that variable in memory the actual 3, whereas an object will have an object here which has certain fields that could be of type integers and type string, and we're going to say that a equals that. And then when we say b equals a, what we actually do is we actually point it to the area in memory which represents the object. So it's a little bit different to primitive types is when we do references as opposed to value. To get your head around that, there's a little exercise for you, exercise D, which looks at references and value consideration. So have a look at that, and if you're unsure, then we'll look to more in the lesson. Otherwise, there's plenty of resources on which we're going to give you access to on the web, which considers this reference and value. I will see you on the next video, where we're going to be looking at the breakdown and understanding of the clock display class. See you then.